Hello and good morning, CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and in this video tutorial we're going to be taking a look at Cisco Learning Labs Discovery Activity number 11, where we're now going to get into the OSPF metric, and we're going to take a look at how OSPF comes up with that metric. I think you're going to be delightfully surprised that it is definitely not as complicated as the EIGRP metric, but there are still some subtleties that need to be taken into account when we look at the OSPF metric. So let's jump on to router 1, our ABR here, and we'll go from user exec into privilege exec. And I just move into global config, assuming we're going to be making some changes here. So let's say do show IP, show IP OSPF, and begin at area. And you can see we have this is an ABR, area border router, so it's going to see area 1, area 2, as well as area 0. And remember, you must have area 0 if you are going to have more than one area. And we will talk about this evening during lecture, that you could set up an OSPF environment and use area 51 or any area number, any non-zero area number. The problem will arise when you decide, oh, I want to add a different different non-area 0 area number. So you have to have area 0 as the backbone area. And we're seeing that here when we have multiple OSPF areas. So we can see how many times the SPF algorithm has run, right? This is how many times we've had some sort of a change in the environment. It could be a link up, a link down. It could be a change in the bandwidth if someone has manually changed the bandwidth. It could be a change in the auto cost reference bandwidth setting, that we are going around and changing what the autocost reference bandwidth should be throughout the environment. We would see, and actually I'm not sure if that would make the change. We'll see if that forces a change in the SPF algorithm or not, but that would change the metric that is going to be used by a specific router. So now what we're going to do is we're going to take an interface down to see that the shortest path first algorithm runs again. So let's get into Ethernet 00, and we're going to say shut. And then let's recall that previous command, excuse me, show IP OSPF begin area, and you can see the SPF algorithm has been executed 5 times. If I say no shut, we bring the interface back up, and we'll let everything come back up here, and we'll let our adjacency, and I guess the Ethernet, yeah, there we go, is connected up, and then we'll say do show IP OSPF begin area again, and yes, so the interface going up, the interface coming up from a down state or going down from an up state is going to force excuse me, or trigger a full run of the SPF calculation. Now, if you've got links that are flapping and you're seeing this SPF algorithm number increase exponentially, then you've got a problem in your environment. In fact, in one of the environments I'm working now, we had an area 0 was simply deployed everywhere. So it was in Alaska, it was in Virginia, it was in DC, it was down in Florida, so it was all out in Nebraska, so it was all over the place. And the problem with that is that when something like this happens, where a link goes up, a link goes down, it's going to force a full run of the SPF algorithm throughout the entire area. So then you've got LSAs being sent all over the place, and it's definitely not good, especially if you've got some sort of a flapping interface somewhere. All right, so now the OSPF link state database has been fully synchronized. So now we're going to talk about the cost, right, and the best path selection. So OSPF by default uses the lowest metric or the lowest cost path to go from its point of origination to the destination, right? What destination am I trying to get to? I'm going to go to the destination that has the lowest cost, or I'm going to go the path that has the lowest cost. And so now this leads us into a conversation as to how is it that OSPF, does it use bandwidth, does it use delay, does it use something other than bandwidth and delay, does it use MTU, right? What does OSPF use? Well, it's very, very simple. And so now that we've seen that the shortest path first algorithm is going to execute, now let's talk about that best path calculation that's actually being calculated when SPF is running, because it's looking for the lowest cost path. And so cost in OSPF is equal to the metric, right? So sort of synonymous terms here. So how do we configure, how do we calculate the cost in OSPF? Well, it's a very simple equation. It is the reference bandwidth divided by the interface bandwidth. And so that raises the question, the logical question, what is the reference bandwidth? Well, the reference bandwidth for OSPF, 900 megabits per second, is 100 megabits per second. Now you're probably thinking to yourself, 100 megabits per second, well, that's obviously not too quick, or in terms of speed-wise, right? Because, I mean, we've got 10 gig, 40 gig, 100 gig interfaces, and you're absolutely right. Anything over 100 megabits per second, so 1 gigabit per second, 10 gigabits per second, 40, 100, all of these interfaces are a metric of 1. Because again, when we divide the reference bandwidth by the interface bandwidth, if we get to the point where we end up with numbers that are much larger than the reference bandwidth, again, we can't get 0, so we end up with 1. And all of these interfaces are treated the same. So, it would be the equivalent of saying, I have a 100 meg interface going this way, and I've got a 100 gig interface going that way, and they're treated equally, right? They're treated the same in terms of metric. So let's go ahead and look at the next step here. And again, the higher costs that you can get to, it's a 16-bit integer, and you can get to 65535, and that is the highest cost that you can get. All right, let's take a look here. So step 3 is where we're at in the activity. So let's take a look at the serial interface here. We're going to say show interface serial 20, and this is where we actually see the bandwidth value. So the bandwidth is 1544 kilobits per second. So we know that serial interfaces is probably T1 interface, right, because of the bandwidth. So it's 1.544 megabits per second. Well, let's take a look at that. If we're dealing in megabits per second, if I said 100 megabits per second divided by 1.544, I get 64.76. Well, let's see. What is the current OSPF cost? So we would say show IP OSPF interface serial 20. And here is the cost. The cost is 64. What did we see the cost at with the calculator? So do we round up or down in this instance? We round down with OSPF. So we end up with 64.76. We clearly round down, but it's 64. And it's that easy, right? Super, super easy. So my point is, if we're saying 100 megabits per second divided by, and if we were looking at a number larger than that, so let's say 1,000 megabits per second, so a gigabit per second, you can see we get 0.1. Well, we can't use 0, right? There is no metric cost of 0, so we simply cap it at 1 in terms of the equation. So it would end up as 1, and that's how, when you get into the larger speeds, everything is going to have a value of 1. So from fast Ethernet to gig-E to 10 gig-E to 40 gig-E to 100 gig-E, we're going to end up with that same value. Now remember, I said that this is by default. That is what's going to happen. If I say show IP route, when we look at some of the costs here, and let's take a look at this guy right here. So you can see that my metric, there's my administrative distance, which is always the first number in the brackets here. There is my OSPF cost. And so for all of the complexity with the link state database and the different LSA types and the different area types, you can certainly see and appreciate sort of the easier metric numbers to deal with when compared to EIGRP, and specifically compared to EIGRP name mode, where things go on a 64-bit scale. So again, OSPF, OSPFv2, OSPF, excuse me, v3, we're talking about a 16-bit scale. So the largest number you're going to deal with is 65535 in terms of the metric setting, right? Now, remember we said by default, so I can tweak things if I have interfaces that are faster than 100 gig, and I want to be able to provide some sort of differentiation between those interfaces. What I can do is I can tweak the auto cost reference bandwidth. So I can change the reference point in OSPF that OSPF is using to perform the calculation. So we'll jump back onto router 1 here, and if I go into global config, router OSPF1, do show run section OSPF. So that's our OSPF section right now. Again, we've got that static neighbor statement. We have some network statements, and now what we're going to do is we're going to add this auto cost reference bandwidth statement. Now, if we do a question mark, you can see the reference bandwidth is in terms of megabits per second. The reason it's in terms of megabits per second, excuse me, is because we're talking about links with speeds, or we would be looking to increase the reference bandwidth for links that have speeds faster than 100 megabits per second. So there's the 100 meg, that would be a gig, that would be 10 gig, 100 gig, a terabit per second, right? So let's back ourselves up here. So we'd say 100 meg, so that is that is what the default setting is right now. That would be setting it to a gig, right? So in other words, I'd be saying that the fastest interface that I have in my environment is a gig. Because if I set it to this and I had 10 gig interfaces, my 1 gig and 10 gig interfaces would then be equal. And clearly, when you've got a factor of 10 in terms of the difference, you don't want those interfaces being treated the same way. And so the activity is asking us to set it to 10,000, which would be 10 gigabits a second. So we'll go ahead and hit enter now. And then you'll notice, this is very important. It says, please ensure the reference bandwidth is consistent across all routers, and that is very, very important, because you don't want some routers using one reference bandwidth and other routers using a different reference bandwidth. You can end up with unexpected results, one of them being asymmetric traffic flows, where traffic egresses in one direction, but then will ingress in another direction due to the fact that the reference bandwidth is being set to a different number. Now if we say do show IP OSPF interface serial 20, the cost that we had earlier of 64 is now 6,476. And let's check that, right? It's always good to have the calculator app up. So the reference bandwidth in megabits per second is 10,000. divided by 1.544 megabits per second, 6476. Again, you can see the 0.68, we do not round up, right? We do not round up. We simply take that integer value right there, 6476, and take a look at that. We've got a match. So what would it be if I were to set it to, let's say auto cost, reference bandwidth, and we're going to set it to, there's 100 meg, a gig, 10 gig, 100 gig. We're going to set it to a terabit a second, right? So before we look at the value, let's pull the calculator up and let's see what that value would look like. So we're going to say there's 100 meg, a gig, 10 gig, 100 gig, a terabit a second divided by 1.544. And take a look at that number. Now, is that number beyond 65,535? It certainly is. And let's see, what number do we get here? So what is the maximum cost value that we can get? You can see we got 647,000, but what does it max out at? Exactly, 65,535. And so here is where we run into the issue. Here's where we run into the issue of we're trying to make sure that the faster interfaces look different from each other. But if in your environment you have a series of slower interfaces in the environment, so a mixture of super fast links and then some not so fast links, some slow serial links, maybe fractional T1, 64K, 128, 256, 512, you can run into the opposite problem, the problem going in the opposite direction, which is now all of my T1 and slower appear to be equal. They're all going to have a maxed out cost of 65,535. So now we have the problem in the other direction. So definitely something to keep in mind. You know, so if you've got a 10 gig interface, and let me clear this out here. Let's say you have a 100 gig interface, and there's 100 meg, 1 gig, 10 gig, 100 gig, divide it by 1.544. You can see that we're almost to the max metric right there. So we need to be really, really careful that if we've got a lot of slower links, that we set it to a good value, or you upgrade the speed of those links, right? So that's how you calculate the cost. And with OSPF, just like EIGRP, we're talking about the destination, right? Or the outgoing interfaces. That is how we are adding up the cost. So as an example, I'm going to come over here to router 4, and we're going to say, we'll get into privilege exec and say show IP route OSPF, and we're looking for that same 192. Yeah, so take a look. So again, we can, the max metric on an individual interface is 65,535. Here we see the total metric, right? It can accumulate to greater than the max metric on an individual interface because, again, we're adding up the hops as we go. So let's take a look. This is going out Ethernet 00. So if I were to say show IP OSPF interface Ethernet 00, the cost is 10. So from router 4 to get to that prefix, that network, my cost out the Ethernet interface is 10. Well, then I know, and there's the network we're going to right up here. So my cost in the outgoing interface here is 10. That gets me over to router 1. Now remember, I don't add in the cost of that interface, Ethernet 00. It's the outgoing interface. Then we come to the serial 20 interface. So let's go ahead and take a look at that. We just ran it. Let's do it. Make sure we did it again here. We've been tweaking the cost there. So 65,535 is the cost there. So what do we have? Is that all we need to add up? And we're going to talk about the loop back here in just a second. So the cost here is 10. The cost here is 65,535. So that gives me 65,545. But what metric did we see? We saw 65,546 because, again, there's the outgoing interface, there's the outgoing interface, and the loop back, which is representing this network segment, we need to look at that. And again, what's the delta here? What's the difference between the metrics? Yeah, the difference is 1, so you can make a pretty good assumption that when we get on to router 2 to take a look at the cost of that network, show IP OSPF interface loopback 0, that the cost will be 1. And that's exactly how you calculate things. And again, you're dealing with numbers that are far more manageable from a mathematical standpoint than the EIGRP metrics in most cases, right? In most cases, and especially in the case of named mode, where everything is going to be scaling to a 64-bit value. All right, so now there's a number of ways. Remember, I mentioned we can change the bandwidth on an interface or on a link. However, the same problem occurs when we manipulate bandwidth. From EIGRP, remember, never, never, never manipulate the bandwidth. You should be manipulating the delay, right? The delay is what you should be manipulating. And with OSPF, it's much the same thing. It's sort of that never, never, never manipulate the bandwidth. Always set the bandwidth to what the actual speed of the interface truly is. But what we need to make sure we do is we tweak the OSPF cost. So here's what we're going to do. We're going to go back to router 1 here, and I am going to turn off, and let me make sure they want us to change it back. Or actually, it looks like they have us leaving it at 1,000, or we leave it set at 10,000. So let's go ahead and say auto cost reference bandwidth 10.123. So we're setting it to 10 gigabits per second. When I say do show IP OSPF interface serial 20, you can see that our cost is 6746. So we've manipulated the auto cost reference bandwidth, saying that in our environment somewhere we've got 10 gig links. And that is how we want to make sure we differentiate between 100 meg, a gig, 10 gig, and so on. And so what we're going to do now is we're going to go ahead and we're going to tweak the cost of the link as well. So let's get into interface serial 20, and you would simply say IP OSPF cost, and let's send it up by 500. So now when I run that command, do show IP OSPF interface 20, and you can see very manageable numbers here. What would we expect to see? It was 6476 before. Now the cost is 500, right? So it's not an additive type thing. When we set the cost, you are overriding whatever the metric was calculated to be. So when I say IP OSPF 500, right, now we have a new cost. And if we tweak the cost, good time to check. If I were to say do show IP OSPF begin area, okay, we've got the executed 10 times. Let's do this. Let's change the cost to 1,000. And then let's rerun that. And so setting the cost is not forcing a full run. So we've got that sorted out. Changing the cost doesn't result in a full run of the SPF algorithm. Over here, when I say show IP route OSPF, now what is our cost to get to that segment? What is the metric? The metric is 1,011, right? Remember, 10 for the outgoing Ethernet interface. We now have 1,000 for the outgoing serial 20 interface, and then 1 for the loopback. So again, very, very simple to take a look at the OSPF topology, kind of walk through the outgoing interfaces, take a look and see what you get. Now, another way to take a look at the cost, and we've been looking at that show IP OSPF interface, is you can still say do show IP OSPF interface, and I can say brief. And you can see what the cost is currently set to, right? And when we take a look at Ethernet 01, you can see that the cost is set to 1,000. If I were to say do show run interface Ethernet, I'm curious as to why that is set to 1,000. Do show run, I thought we set it to 10,000 in our auto cost reference bandwidth. Do show run section OSPF, and it is set to 10,000. Yeah, so that is interesting. The reference bandwidth is set to 10,000. The cost, oh, because we changed, I'm sorry, because we changed it, I was thinking that we had added to Ethernet 01, and we did not. So this is actually good that we run into this, right? So we see the cost here, and where are we at, of Ethernet 01, and I saw that cost of 1,000. I was like, wait a second, we didn't set it. Did they already set it? And the answer is no, it wasn't already set. That's why I did the show run here on the interface. What I was discounting was, what did we set the reference point to be? Now remember, this is an Ethernet interface, right? It's a regular Ethernet interface. If I were to say, do show int Ethernet 01, what is the bandwidth on this interface as it is? And then remember, that's in kilobits per second. So 1, 2, 3, this is a 10 megabit per second Ethernet interface. So the reason that we're seeing the cost up here as 1,000, and let's bring our calculator back. Remember, the our auto cost reference bandwidth, our reference point for OSPF is currently set to 10 gigabits a second. When I divide that by the actual bandwidth statement, or the bandwidth value of this interface, what do we end up with? Well, it's 10 megabits per second. There you go. That's why the cost is showing up as 1,000. So again, I had set it on the serial interface, and then when it came up in the output of that command, interface brief, I was like, wait a second, why is it 1,000 on all three of those? I only set it on the serial 2.0. But the reason these two 10 meg Ethernet interfaces are at 1,000 is because we changed the auto cost reference bandwidth. All right, so now we're back on track here. And so to prove that, if I were to go back into router OSPF1 and say auto cost reference bandwidth 1,000, so we'll set it to a gigabit a second, right? Now when I say do show IP OSPF interface brief, the costs of Ethernet 00 and Ethernet 01 have now been adjusted down, because those equations, again, the reference bandwidth of 1,000 divided by the interface bandwidth of 10 megabits a second gives us a cost of 100, right? Okay. And so, as you can see, it's very, very straightforward. It is not that difficult. It's outgoing interfaces. We don't look at delay, right? OSPF does not look at delay as part of its calculation. It is simply taking the bandwidth of the interface and dividing that, or I should say, taking the reference bandwidth, which is by default 100 megabits a second. It's taking that value and dividing it by the actual bandwidth of the interface. And so when we get into larger values, anything over 100 meg, and I know I've always asked that question, why would they not change that? You know, why would they not make an adjustment in one of the releases of OSPF at some point so that the reference bandwidth, you know, and again, this is universal across all vendors, right? You know, why isn't OSPF by default, why isn't it set to maybe a gig? That would seem like a safe setting in today's networks. And then if you needed to adjust it down, then you could do so. All right, that's going to wrap up discovery activity number 11 on the OSPF cost, and I should say on the OSPF metric, and how we can manipulate the metrics in order to have one path chosen or selected over another. All right, thanks for watching, and I'll see you guys this evening.